So what does that mean is that here you have, let me show you, this is your sentence number one, and then your sentence number two. Within your sentence number one, if I choose a word like this word is actually asking a query. This word is asking a query. What is that query? This word it is actually asking a query. What is that query? The query is that I'm asking to each and every word, it will go. It will first come, ask this query, to whom? This A. Hey, are you similar to me? Do you have any relationship with me? Then it will ask this to this dog. Hey, do you have some relationship? Then with it, then with the, then with food, then with because, then with it, and keep on asking the same thing to each and everyone. And how? So we are doing it in a way in which each and every word, which is something like this, we will take any word like this and see this word in three roles. What are those three roles? First role is query. Second role is key. Third role is value. Okay. What are these rules? I will give you some example by which you will understand. But first of all, let us understand what we need to do. When this guy is asking query, this it is having a representation. Let me write that representation as x of it. That is a representation. Now this x of it cannot be seen single way, because it is going to be used in three different roles. Sometimes it is query, sometimes it is key, sometimes it is value. Then I apply this query function over this xit. This is going to give me x query it. Okay. Now for each of them, I will apply key of xa. It's going to give me key of, it's going to give me, please keep on writing, x key a. Similarly for this, when you apply key function over this, you will get x dog. Believe me, if you are writing, you will be able to understand. X key dog. This, it will become key x because is equal to x of because key value. What we are doing? We are, when we are doing this stuff, that for it, I am computing this, it is computing its relevance, its dependency with dog. I will take the dog's actual value. What is this actual value? The actual embedding, where it is written. It must be written in my x somewhere. I take this dog's actual embedding, apply key function over that, and I will get the key value of this dog's embedding. In this way, what we are going to do is that for it, I will take its query value. And for all these guys, I am taking their key values. And remember that again, this it is going to come over here. But this time from here, you have taken its query value. Here you are taking its key value. And what you are going to do, when I take this, I find out its distance with this vector. Which vector? X, Q, I, T and X, A, K. Simple. What we are doing, I'll take a word, apply query, I will get its query information, and matching that query with each and every word's key information. How to get this query and key, forget, I will tell you. But if you have someone, what you are doing, this guy is querying what, hey, are you same to me, are you same to me, how close you are, how far you are, how near you are, how much attention I have with you, how much relationship I have with you, do I have any dependency with you. These all questions are being asked. Between it and all of them, so it is asking a query, so we need to take its query value, and all these guys are going to present their key values, and then we check that the query value of this, how close it is with the key values of them. And this is going to tell you what is the attention or the dependency or the amount of dependency that you have between it and any of these words. Yeah, so if we understand this, which means that we have a query, we have a key and a value, the same thing, same word I is actually having a query value of I, a key value of I, and its value also. I just have till explained you how these two things are being used. I will talk about that, but each and every word, let me ask, when I take food and finding out how this food is related to a or dog or ate or this. Now, food is going to be related to whom? Let us talk to someone. Richa, can you listen? Richa,
Yes, sir.
my point is that this food, when we talk about this food, you understand that it's query we are going to take.
Sir, you are
We,
asking query?
yes, we wanted to know food's relationship with all of them.
Yes, sir.
Then if that is the case, then we are going to take the query of food, right?
Yes, sir.
And these guys are going to give their which value?
Key value, sir.
Their key value, fine. So can you tell me that food is going to have high relationship with whom? Whose key value it's going to have high relationship? What are those words?
Sir, ate and hungry maybe?
It may be hungry, it may be ate, it may be even dog, because who is taking the food?
Yes, sir. Yes, sir.
So food may be having, ate, maybe dog, maybe hungry. It's going to have, some sort of relationship with them. Others may not be big, which means that the query of food need to be high with query of food when compared with the key of dog, ate, and hungry need to be high, else it need to be low. We need to somehow do this stuff. And if that is the case, which means that these words are actually learning their relationships properly. Yes, so if that is the case, let me give you a very simple
Sir,
few. Yes, Puchu
who
Puchu.
defines the value of key?
Yes,
I mean,
that's true.
when I'm saying X, a dog,
Yeah,
how will I get this? What is this entity?
yes, that's true. So that is the thing, that is the central question right now. So I request that अभी हम लोग इसको लिखते जाते हैं, and in 5 minutes you will be able to understand.
Sure.
Yes, yes. So your I am good right now. I use two example. One, that dog example, to show you the relationship, and I cannot use that big sentence to write all the steps in transformer. So I'm using a simple sentence, that I am good, and the corresponding French version. So I am good 1.76, 2.2, keep on, and 6.6. Why? What is this? What is this? This is the representation. That is my xi. Okay. Or you can say x1 as well, because it's a first word. 7.77. These numbers are just to, represent. I mean, they doesn't mean much. I just wanted to write so that you all can understand these can be any type of number. I'm just writing arbit things. This is the
And
encoding of
these values are the relationship between what you have written on the left hand side and the same sentence, other words in the same sentence.
no. These are the simple embedding. They are my x input things. This is my input. Thank you. Keep on asking. जैसे जैसे आप पूछते जाएंगे मैं आपको बताता जाऊंगा.
So
जहां पर भी yes.
what does 1.76 denote? A relationship
It doesn't
of
really.
I?
No. Not any relationship. They are randomly initialized and being learned during the period of time. But they are the representation. This is the meaning of I. That when you take any word, it is having its own relationship independent of any dependence. So right now it is some randomly initialized value. It can be initialized using word to vec or glove type of embedding that you are going to use maybe today in our RNN assignment, the lab assignment as well. But right now this is just the embedding. Embedding nothing, plain simple embedding which is having some value related to M, related to good, related to I, something like this.
Yeah. What are the columns? Rows, I understand it is for everything
Yeah, that
related
is the
to I.
dimensions. Yeah, 512 dimensions. So which means that I have some sort of neural network which is taking I and giving me a 512 dimension thing out, which is saying that whenever two words which are very similar goes inside this network, I am going to give you 512 distinct things, but they will be very close. And if they are very far, king and queen, their embedding 512 dimension embedding will be close. So if I take this 512 dimensional space, king and queen will actually be close, and the words which are related, they may be close things. Words which are very far, they will be different, and they will be having some distance from the far words. This is word embedding, and it's something different. Word embedding just says, again I am writing word embedding, and one more concept, that without context. So each word have its own embedding. King have an embedding, queen have an embedding, and if I take this king and queen embedding, some network is taking this word king or queen, projecting into some high dimensional 512 dimensional space where king and queen, they may be similar. But the point is why they are similar, because king and queen are having an inherent relationship. It doesn't matter whether they come close in some word or sentence or not. Like apple and orange, they are having two different embeddings. How close they are, it depends that how two fruits are that much close. If I give you Sachin Tendulkar and Virat Kohli, they may be close. But if you give Sachin Tendulkar and Albert Einstein, they may be very far. So the point is, the requirement of this network is different, and that is a different area which is called as word embedding. We are not focusing on that, but believe me that whenever you wanted to use any network to see I or any English word, any word need first to be converted into embedding, and these are called word embedding. There are multiple word embeddings. One was word to vec. It will just take a word and convert into vec. Other one is glow. So these two embeddings are most of the time being used for any recurrent relationship. If you wanted to generate language to language or any other model using RNN or LSTM, so you will be using word to vec encoding. In the case of transformer, you can use random as well as these type of embeddings as well, but these embeddings are actually being learned within the network itself. आप पूछिए.
So I have one question here on that matrix which you drew a bit earlier. So in a particular row, it is just the representation, say, of the word I or good, independent of
Yeah,
others, right? In this
that's
context.
true. That's true. That's true.
Okay, just a way to map it into a 512 dimension space.
Yes, that's true.
Okay.
Sir,
Yeah. Yes.
sir, we started with initial embeddings, right?
Yes.
And sir, if I talk about any word in our input sentence, then
Hmm.
we are kind of applying query to some words and applying key, which is kind of we
Yeah.
are transforming them, vectors, we are
Yes.
transforming them.
Yes.
Uh, sir, what is the logic behind this transformation? Like,
Yeah, I will tell you that. Don't worry.
okay,
Yeah,
sir.
we will talk about. I will take an example and explain. But your question is that I, and then you apply query, then key, then value, and when you take any word in this sentence, you take the query of this. Let me rephrase, right? And then all these words, then you take the key of them. All of these things, they are keys. And then query to key, we match. And then tell that the score. So here this will be S1, here this will be S2, here this will be S3, here S4, here this will be S5, here S6. These are the scores. What are these scores, by the way? If I give you two vector, you just do the dot product and cos theta is anyways going to come. And that is actually the score. That's the score. So if this score is high, they are related. If that score is low, they are not related. Your question is that why query, key, and value, three different things. Is that okay?
Sir, my question is why this query and key product that we are calling as attention score,
Yeah.
why is it working? Like,
Yes, I know. I understand. That is the point. I will give you an
yes.
example. With that, we will understood. But first, we need to understand that what we are doing.
Okay, sir. Okay.
Right. So I understood that your question is this. Oh, where it is. Okay. Yeah. So your question is that why to three things, why not to five things, why not to 25 things, and so many. So we will talk about that. But what we are doing is that we take query key, and between this query key, we find out, because query will convert input embedding of the word into its query representation, its key representation, its value representation. And when you wanted to find out attention of any word with respect to all the other words, I take its query, other words key, and then find out its dot product. Anyone is having any question over here, please let me know. Simple.
Yeah, I just need to